This video lecture is meant to expand upon the concept and calculations from the basic tutorial of percent yield. So in this is an advanced tutorial and practice problems that we're going to try here. Let's see, we're going to first recognize that the first three problems we gave you the percent yield values. That's what we calculated, but in these remaining problems you're going to have to calculate the theoretical yield using stoichiometry. So let's give it a go. Problem number 4. If the reaction below uses 20.0 grams of lithium hydroxide and an excess of potassium chloride. So what we know is that we have 20.0 grams of lithium hydroxide and we have an excess amount of potassium chloride. How much lithium chloride could be theoretically made? So right now we could care nothing about this potassium hydroxide. What's this business about the excess potassium chloride right here? Well, the idea is that we have so much of it, it's not going to limit our reaction, and what it means is that all 20.0 grams of the lithium hydroxide are indeed going to get used up. So here we are going to use our 20.0 grams of lithium hydroxide. We're going to do a 3-step stoichiometry problem to figure out how much lithium chloride we could theoretically make. Once we have that number, we can apply it to the percent yield problem and do the actual problem in question. All right, 3-step stoichiometry first has us converting grams of lithium hydroxide into moles of lithium hydroxide. So I'm going to put grams of LiOH in the denominator and moles of LiOH in the numerator. It's always 1 mole is equal to the molar mass of lithium hydroxide, which when you add up 1 lithium, 1 hydrogen, and 1 oxygen, you get 23.9 grams. The next fraction, we'll take our 1 mole of lithium hydroxide. The 1 mole I'm referring to here comes from the fact that this is a balanced equation of 1 to 1 to 1 to 1. So 1 mole of lithium hydroxide converts to 1 mole of lithium chloride. So these right here, of course, come from the coefficients of the balanced equation. Last conversion fraction is going to convert us from moles of lithium chloride to grams of lithium chloride. And when you add up the mass of 1 lithium and 1 chloride, you get a molar mass of 42.4 grams. Okay. Of course, if we show everything canceling, grams of lithium hydroxide will cancel, moles of lithium hydroxide will cancel, and moles of lithium chloride will cancel. In your calculator, if we mind our significant figures, started with 3 sig figs here, so we're going to end up with 3 sig figs, and in your calculator you should get 35.5 grams of LiCl. So this number right here represents your theoretical yield. That we can then use in our percent yield problem, which is part B. Okay, so here it turns out that in the experiment only 6.0 grams was actually produced. The math tells us we could have produced as much as 35.5 grams. Putting it into percent form, we multiply by 100. We're limited now to 2 significant figures because 6.0 has only 2 significant figures, so this works out to a 17% yield. So not a very good percent yield, but it is what it is. All right, I'm going to have you try problems 5 and 6 on your own and bring them to the teacher, but before you do, we're going to carry on to the next part of this problem set, which is putting together the ideas of limiting reactant and percent yield. So this is where we're taking it up yet another notch. All right, so all of the questions, we're on problem number 7. All of the questions in this problem involve the following unbalanced reaction. Okay, so I'm telling you this is unbalanced reaction, and this is really important. We need those coefficients. So if we take a look here, if we have 1 copper, we have 1 copper, 2 chlorides, but only 1 chloride over here, so we got to put a 2. 2 sodiums, now I'm going to have to put a 2 there. So this works out to 1, 2, 1, 2 as your coefficients. Here's the question. It says, what is the limiting reagent if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate? So what we're telling you here is that you go to the pantry and you find that you have only 15 grams of copper chloride on hand, and you have 20 grams of sodium nitrate on hand. So you want to know which one's going to run out first. That's what we mean when we ask what is the limiting reagent. So to do this, going back to the first tutorial in this series, the first thing you have to do is you have to take your quantities given, 15 grams of the CuCl2, and we're going to convert that to moles. Right? So it turns out that 1 mole of CuCl2 has a mass of 134.5 grams. So when we do this math, we get 0.11 moles of CuCl2. All right, now we're going to do it for the 20 grams of sodium nitrate. 1 mole of sodium nitrate has a molar mass of 85.0 grams of NaNO3. And so here we come out to 0.24 moles of NaNO3. Now to figure out the limiting reactant at this point, you can't stop here. You have to divide each of these mole quantities by the coefficients from the balanced equation. So dividing the copper chloride by 1, we of course are going to get 0.11. And dividing the 0.24 by the coefficient of 2, we're going to get a 0.12. So since 0.11 is smaller than 0.12, we are now moving forward as if the copper chloride is our limiting reactant. So the answer to this first question, who is the limiting or what is the limiting reactant, is CuCl2. Will be limiting, and we'll have an excess of the copper chloride. So now the next question says how much or how many grams of sodium chloride can actually be made. So the hint here is to use the limiting reagent mass to start our stoichiometry problem here. So the limiting reagent mass was the copper chloride, the 15 grams of copper chloride. So 15 grams of copper chloride is where we're starting, and what we're trying to find is the mass of sodium chloride that we can make if we use all 15 grams of copper chloride. So this is a 3-step stoichiometry problem. It turns out that 1 mole of CuCl2 weighs 134.5 grams. Now we want to use our coefficients from our balanced equation. We have 2 moles of NaCl. That's this coefficient right here. We're going to divide that by 1 mole of CuCl2. That's that coefficient right there. The last step is to convert moles of NaCl into grams of NaCl. So 1 mole of NaCl weighs 58.5 grams. So when we do this, this works out to, if we maintain the 2 sig figs that we started with, we should end up with 13 grams of NaCl theoretically produced. So now the next part of this problem says if 11.3 grams of sodium chloride are actually formed in the reaction, what is the percent yield of the reaction? So remember, the actual yield goes in the numerator. The theoretical yield was the number we discovered by the stoichiometry, so 13 grams. And then putting it into percent form by multiplying by 100, maintaining 2 significant figures, this is an 87% yield. Now, if we want to take it up even yet another notch, sometimes limiting reactant problems will want you to figure out how much of the excess reactant was used and or how much of the excess reactant was still left over. To do this, you're going to do a stoichiometry problem from the limiting reagent mass. In this problem, that was the CuCl2, the 15 grams, to find out the mass of the excess reactant used. Okay, so in this case, the excess reactant was the sodium nitrate. So that's what we're trying to find, is X grams of sodium nitrate, right? And that'll tell us how much sodium nitrate was actually used. So let's set up that problem. Starting with 15 grams of CuCl2. First step is to convert that to moles. That's 134.5 grams of CuCl2 in 1 mole. CuCl2. Now we're going to use the coefficients from the balanced equation. There are 2 moles of NaNO3 in the balanced equation to 1 mole of CuCl2. That's the coefficient, again, the coefficients from the balanced equation. And now we want to convert moles of NaNO3 into grams, so we need the molar mass, which is 85.0 grams NaNO3 in 1 mole, right? And this is going to tell us that if we use up all 15 grams of copper chloride, we can make 19 grams, or we'll need, we won't make it, we will need 19 grams of NaNO3. So that's how much will be used along with the 15 grams of the copper chloride. Now remember, they told us in the original problem that we needed 20 grams, or that we were given 20 grams of sodium nitrate. I'm going to go back up to the top and show you what I'm referring to, right up here at the top. 20 grams of sodium nitrate was our original supply of sodium nitrate on hand. So we're going to go back down to the problem below. And so if we, because the question is actually asking us how much or how many grams of the excess reactant was used in this reaction. That's this answer right here. But then the second question says how many grams of the excess reagent was unused in this reaction. So since we were given 20 grams to start and we used up 19 grams, then there's going to be 1 gram of sodium nitrate left over. So those are the two answers there. All right, so you have problems 5 and 6 and problem number 8 to try. Show those to your teacher to get full credit, and we'll see you back in the classroom.